Hi, this is Mrs. Milton, one of the Algebra 2 teachers at Eden Prairie High School. I am super excited to be, and nervous to be making videos for you to watch for Chapter 5. I'm using programs that are new to me. I am definitely learning as I go, so I appreciate your patience and your grace when these are maybe a little bit less than stellar. Chapter 5 is all about quadratic functions. You can see some parabolas on the screen here, and hopefully that's making you smile inside because you've already done a lot of work with quadratic functions. Hopefully they're familiar to you, you recognize them as parabolas, and we're going to spend this chapter digging a little bit deeper. I really enjoy this chapter, and I hope you do as well. Everything we do is going to stem from that parent function again of y equals x squared. Yikes. Hopefully my writing on this pen will improve as well. All right. When I look at this slide, this is a really nice graphic that kind of condenses the chapter onto one picture. We're going to spend all of our chapter talking about quadratic equations, and quadratic equations have so much information about them that we actually have three different equations that could represent. Vertex form being one of them, standard form another, and intercept form a third. The nice thing is that vertex form of a quadratic function you already know about. You've spent a lot of time dealing with vertex form. Standard form you saw a little bit back in chapter 3 when we used our calculators to find functions of best fit, and our quadratics came in standard form. Intercept form will be new, but we'll teach you it today. You'll catch on just fine. One goal of the chapter is for all students to be able to comfortably go back and forth between the different forms of quadratic functions. So for example, I may give you something in intercept form and ask you to write it in standard form, and even maybe ask you to write it in vertex form. We will work on that. Today, we're going to focus a lot on graphing these functions. Let's see. I'm going to go here. This slide is definitely worth writing down. You have the three forms of a quadratic function. I think you already recognize this vertex form right here from chapter 3, where you can remember we have y equals, let's try to change that. Y equals a times the quantity of x minus h squared plus k. Hopefully you remember that the a represents the stretch or the dilation, and h comma k represents the vertex. You also have had a little bit of experience with general standard form. In this one, we have y equals ax squared plus bx plus c, where you can remember that a, the coefficient in front of the x squared, is still the stretch or the dilation. One cool thing we're going to discover is that c, the constant at the end, is actually your y-intercept, and then you're going to learn kind of a fancy way to find the vertex. When you're in vertex form, you can look at the equation and just see it with your h comma k. It's not quite as simple in standard form to find that vertex. And then lastly today, we will deal with factored or intercept form. That also gives you different information about a parabola. One thing we will talk about, and you'll learn that the a value out in front is still your stretch or dilation, so that is consistent. And then we've got our binomials that will actually give us our x-intercepts. So intercept form, we're pretty creative naming it. It helps you see where it crosses the x-axis. All right, let's see. Last thing for this video, this should be a little review from chapter 3. Almost all of this is stuff you are used to. If you have the parent graph, y equals x squared, in standard form, that would it would be y equals 1x squared plus 0x plus 0. So it just reduces to that y equals x squared. You know that parent graph has a vertex at 0, comma 0. The axis of symmetry, that's new. I'll come back to that. Number 3, this parabola is going to open up. We know that because our a value is 1. If your a value is positive, you'll open up. If the a value is negative, you'll open down. Since this will be opening up, we know that vertex gives us a minimum value. And then the pattern of change for parabolas is always the 1a, 3a, 5a. So since a is 1, we have a pattern of change of 1, 3, 5. So if you remember from the vertex, you count up 1 over 1 to the right, then up 3 over 1, and then you would count up 5 over 1, but we've run out of grid. And then you do the same on the left, up 1 to the left, up 3 to the left, and then up 5 to the left. When you draw your parabolas, you don't want these to look like V's. They're not. They're nice U-shapes, so try your best to get a nice U curve. Put arrows on the end, because this parabola is going to go on forever, up and out. So the last thing I'm going to go back to is to talk about this idea of axis of symmetry. If I folded my graph horizontally on the y-axis here, you could see that the parabola is symmetrical. This point here would match up with that point. This point here would match up with that point. So that's why the axis of symmetry is the y-axis. That's going to be, the equation is x equals 0. Please always put the axis of symmetry in equation form, x equals, and one thing, a pattern you will notice is that the x value of the vertex, and the axis of symmetry will be the same. That, I believe, is going to be all for our first video. Thanks so much. Go on to the next one.